Hello there, today we're going to be doing a candy chromatography experiment. In this experiment, we will first learn what chromatography means. Chromatography is a Greek word. Chromo means color, graphy means writing. Chromatography is a simple way to separate two components from a mixture. In this experiment, we're going to be separating the different colors in the Skittles. What you need for this experiment are a cup of water, tape, Skittles or M&Ms, coffee filter paper, a pencil, straws, 5 glasses, 1/8 tablespoon of salt, a pipette. So the first thing we're going to be doing is we're using our 1/8 tablespoon of salt, and we're going to be dumping it in our 300 milliliter water. So the reason why we're using salt for this is because salt can stick to the components much more better and can stick to the coffee filter paper much more better than regular water. So the next thing you're going to do is cut these coffee filter papers into strips. We've already done that.
Each color candy in a different cup. And I have put 5 cups. And I choose red, orange, brown, yellow, and green. In your pipette, take a single drop of water, like only 1 drop of water, and put it in Skittle or M&M cup. Did you put this?
No.
Okay, so wait for 2 minutes, and the Skittle color will dissolve in the water, and you can see all of its colors.
We had to add a little bit more, like a bit more than 1 drop of water, because that 1 drop was not sufficient. However, as you see, it is slowly starting to progress. You can see all the coating on the Skittle is actually wearing off, and you can see the white stuff inside of the Skittle. The next thing you're going to do is to take your coffee filter papers and draw a 1 centimeter line over here. So this is a mark that I put, so I know it's 1 centimeter. Then we're just going to draw it. You're going to want to do this for all of your coffee filter paper.
We just dropped each the M&M water in each filter, in each coffee filter paper.
Now that we have this, we're just going to be wrapping it around. Yeah, I can give you a tape.
Okay.
And just going to want to tape it so it sticks. Just sticks. Okay, and the next step you should do . The next step we should do is to dump the saltwater solution into the box and put these on top over here. Just put the coffee filter paper on top, like right here. And as you see, these coffee filters, they are barely touching the water, so this will give the water enough time so that it can rise up. And this rising water, even though gravity pulls everything down, when water rises, it's called capillary action. So we're going to wait for some time, and then after some time, when all the water is risen up, we are going to move these coffee filters off, and we're going to let it dry and observe them. It's been a few hours since we got these coffee filter papers outside and let it dry, and as you see, we observed some changes over here. So red and yellow are actually primary colors, so we don't expect much from them. However, a green, orange, and purple are secondary colors. So there were colors inside them that dissolved out. On the green coffee filter paper, we see blue right here and yellow right under it. And then for the purple one, we saw the red right here and the blue right here. And for orange, well, red and yellow creates orange. We didn't see a lot of yellow, but we did see some faint red. Blue, it traveled much more farther than green or yellow. The reason why blue traveled much more farther than yellow is because blue must have dissolved much more quickly than yellow. these are the observations that we found out on the coffee strips. In real life, sometimes these scientists, they actually do research on the virus. They have to use the chromatography technique to understand each simple part of them much more better. People in the medical industry use it on drugs or medicines, and people in the food industry use it on how many vitamins or what types of preservatives are inside the food. Now let's have a yummy dessert. That's pretty good, man.